Hi everyone. My name is Yingbin Zhang. I'm a PhD student in the University of Illinois at Urbana-Champaign. So before I start, let me ask you a question. Do you think confusion is good to learn in? Think for several seconds. Some of you may answer yes, some of you may answer no. Well, both of you are right. Confusion can both facilitate and harm learning, depending on whether learners can resolve confusion, whether they can get through it. So our work is about whether metacognitive strategies can help students resolve their confusion. So confusion, like I said before, confusion can benefit learning, but only when it is resolved. How confusion can be resolved? To answer this, we need to know what causes confusion. So when learners meet new information that is inconsistent with their existing knowledge structure, their cognition become dissonant, and the dissonant state in turn may lead to confusion. Therefore, confusion resolution means learners or students can successfully reconcile the discrepant information and the existing knowledge structure. To resolve confusion, students need possess necessary knowledge or skills or receive external help, such from the teacher or from the learning environment. And some researchers suggest promoting self strategies to help learners resolve the confusion, and thus promote deep learning. However, there is little direct evidence support that self-regulated strategies can improve the chance of confusion resolution. Then metacognitive strategies refers to the procedural knowledge of how, when, and why to regulate cognition. So for convenience, I refer to it as MS. In general, its components include goal setting, planning, self-monitoring, self-control, and self-evaluation. MS may help resolving confusion under the framework of two-level metacognitive system. So, sorry, in this figure, there are two ellipses. The gray one, the one in the bottom, represents the object level, and the object level contains models or knowledge about the world, while the black one represents the meta level. It contains models or knowledge about the object level. For example, in a student's meta level, a model may be that it is helpful to take notes while learning new knowledge. The meta level has two functions. The monitoring function receives information from the object level. The control function sends order to the object level. For example, when a learner meets a new concept, or when a learner meets a concept, if the learner is monitoring the cognitive process, the information about the concept will flow to the meta level, and the meta level judges whether the concept is a new concept or not. If it is, the meta level may send the commands to the object level to activate the tactic of taking notes. The control function manifests as MS behavior. Recall that confusion arises when new information is inconsistent with their existing knowledge structure, and confusion resolution means students successfully harmonize the new information and the existing knowledge structure. Then, under the framework of the two-level metacognitive system, learners need to activate MS behavior to resolve confusion. They need to use control function to inform the object level how to restore to cognitive equilibrium. In addition, confusion may co-occur with the change of mass behavior based on the metacognitive and the affective model of self-regulated learning. This model emphasizes the interaction of affect, motivation, and metacognition in self-regulated learning. It assumes that cognitive disequilibrium may trigger both feelings and affective reactions, and which in turn may motivate self-regulation of behavior and emotions. So, on this theory, it is reasonable to expect that learners may change their MS behavior when they feel confused. So the current research examines the association between confusion and MS. 3 questions. The first one is the frequency of MS behavior different when learners feel confused and when they are not confused. The second one is confusion resolution related to more MS behavior. And if MS contribute to confusion resolution, then the effect of confusion on learning may depend on students' MS. Thus, the third research question asked, can MS modulate the relationship between confusion and the learning? Okay, both the second and the third question is about can MS help learners resolve confusion. The second is at fine granularity. The third is at coarse granularity. So this study is conducted within an open-ended environment batch experience. So in batch experience, students need to teach a virtual pedagogical agent Betty some scientific phenomena such as climate change. To teach Betty, students need to build a causal map in the blank page. And this blank page is Betty's brain. So this is a causal map. And in the map, causal relationships are represented by concepts and directed causal links among these concepts. Students can fluidly and delete add and delete concepts and the links. And in the left bottom, you can see Mr. Davis. Mr. Davis is a virtual tutor. He may provide feedbacks to prompt students to do some actions. And in order to know the correct relationships among the scientific concepts, students need to read the text. And this is a textbook or the resource book. Students can evaluate their causal map by having Betty to take quizzes. And by looking at Betty's correct and incorrect answers, students can identify problems in their causal map. For example, in these quiz results, the link between deforestation and carbon dioxide was wrong. So the data of this study was from 93 sixth grade students. The study lasted 7 school days. In the first day, students completed a playtest. Next day, they received a training session on how to use Betty's brain. And in the next 4 days, they used the Betty's brain to learn climate change for around 45 minutes per day. In the last day, they completed a post-test. So while students were using Betty's brain, their researchers observed and recorded students' emotions in a predetermined order. And there are in total 326 observations and confusions, and over 4,000 observations of other emotions, include engaged concentration, frustration, boredom, delight. and the emotion data was aligned with the log file in timeline. And the log file of students working on batch sprint was used to generate MS indicators based on coherence analysis. So coherence analysis interprets learners' behavior based on the relationship between actions, such as the relationship between reading the resource page and editing a link. So for to audit the actions, such as for to audit the actions X and Y, if the second action Y utilizes information generated by the first action X, then X, we can say X supports Y, and X and Y are coherent. The two audit actions do not need to be two consecutive actions. For instance, in batch sprint, the quiz results here, we talked before, the link between deforestation and carbon dioxide was incorrect. Then if one student, after viewing the quiz results, if this student read the resource page that demonstrates the relationship between deforestation and carbon dioxide, then the action of viewing the quiz result and the action of reading the resource page are coherent. And say a coherent analysis assumes that the action coherence may indicate MS and the task understanding. If one student shows two audit actions that are coherent, it means he or she monitored the previous cognitive processes, such as viewing the quiz results and the received information generated by viewing the quiz results. Thus, the link between deforestation and carbon dioxide was wrong, and is controlling the current cognitive process. Thus, for example, thus reading the resource pages that demonstrates the relationship between the two concepts. Therefore, coherent actions may be the indicator of MS behavior. And in this study, we identified 5 metrics related to MS behavior. And the first 4 was based on coherence analysis, the frequency of coherence reading, thus the number of coherent reading per minute, frequency of coherent editing, that's the number of coherent editing the link. Coherent marking is the frequency of how frequently students mark a link as wrong or correct or maybe wrong. It reflects how often students, based on the quiz results, understood what links on their map were correct or possible incorrect. The frequency of coherent viewing is the number of viewing quiz results actions that were coherent with later actions per minute. And this variable measures how often students collected the assessment information that was used later. The final one, quizzing frequency, is the number of taking quiz actions per minute. It reflects how often students evaluate their own understanding. Although it is not based on coherence analysis, it is usually thought as a strategy for monitoring current progress. The pretest and post-test were identical in both content and form. It assessed the knowledge of climate change and causal reasoning. It contains multiple choice questions and short answer questions. Students can get a maximum score of 16 within each test. So for the first research question, is the frequency of MS behavior different when students are confused and when they are not confused? So same metrics were calculated within a window, including 30 seconds before and 30 seconds after an emotion observation. and the frequency. For example, the same matrix within confusion is the same matrix within a window, including 30 seconds before and 30 seconds after the confusion observation. Then we compare this matrix for the observations of confusion and observations of other emotions. This is the results. So you can see the cognitive viewing is more frequent when students are confused. Its frequency was 0.52 per minute when students are confused, compared to 0.26 when students are not confused. Also, students also did more coherent reading when they are confused, indicating that students were more likely to read the text based on quiz results when they were confused. So for the second question, is confusion resolution related to more MS behavior? Prior research has found that resolved confusion may transform into engaged concentration or delight, while unresolved confusion persists and may transform into frustration or boredom. So if observation of confusion is followed by engaged concentration or delight, then this confusion may indicate a resolved confusion. While if an observation of confusion was followed by confusion or frustration or boredom, then this confusion may indicate unresolved confusion. So we compare the same matrices between resolved confusion and unresolved confusion. However, none of the 5 matrices was different between resolved and unresolved confusion. So this confusion resolution was not related to the frequency of MS behavior. For the third research question, can MS modulate the effect of confusion on learning? We applied the principal component analysis to extract an effect from the 5 matrix, and this factor was used as the indicator of MS. Then confusion scores is calculated as the percent of confusion observations in total emotion observations. We divided students into 4 groups depending on whether their MS score is higher or lower than the median. Their confusion score is higher or lower than the median. Then we using the MS and the confusion as the independent variable, the test score as the dependent variable. We conducted the repeated ANOVA to give them the effect of MS and confusion on learning. So before showing you the ANOVA results, let's look at the different groups test scores. In the left panel is for high MS group, right panel for low MS group, and the blue line or the green line is for the low confusion group. The red lines for the high confusion group. And in the left panel, it is clear that high confusion group has lower test scores, has lower pre-test scores than the low confusion group, but this difference disappeared in the post-test. While in the right panel, in the low MS groups, there isn't a significant difference in either pre-test scores or post-test scores between the high and low confusion groups. So in terms of this figure, it seems that MS did moderate the effect of confusion on learning. However, the interaction of MS confusion and time was not significant, although we may call it marginally significant if we decrease our criterion. However, we need to be careful to say that MS can moderate the effect of confusion on learning. So in summary, this study found that confusion was accompanied by changes in MS behavior, but confusion resolution was not related to MS behavior. More MS behavior didn't resolve confusion, and MS also did not moderate the effect of confusion on learning. So taking these results together, this study suggests that MS may be necessary, but not a sufficient condition for confusion resolution. This study has several limitations which limited the generality of the results. So the first one, confusion didn't frequently occur in the current study. Even in the high confusion group, observations of confusion only accounts for 6% of total observations. Then with such low percent of confusion, confusion may actually didn't have any impact on the learning outcomes. Actually, in the novel results, we found that the main effect of confusion was not significant, and also the interaction of confusion and the learning also not significant. And the second limitation is for the research question 2. In some cases, an observation of confusion followed by engaged concentration or delight might be some students shifted their focus without resolving the cognitive disequilibrium. So this confusion can represent resolved confusion. In the log file, we can't identify whether students are just shifting their focus or they are really trying to resolve their confusion. And the third one is, in this study, we didn't have a cognitive or motivational factors or variables. However, in terms of self-regulated learning, cognition, motivation, metacognition, and affect, these factors, they mutually infect each other. They interact with each other in the learning process. And finally, the participants of this study was from 6th grade students. Well, the proficiency of 6th grade MS may be not strong enough for them to resolve confusion. And to conclude, this study has two implications. First one, the results for this question 1 provided evidence for some assumptions of the MASRL model. This theory assumes that cognitive disequilibrium may trigger metacognitive experiences and affective actions, which in turn motivate self-regulation of behavior and emotion. Recall that in the results for research question 1, students' coherence reading behavior and coherence viewing behavior was different when they are confused and when they are not confused. Secondly, this study also suggests that if you want to take advantage of confusion, you should consider whether students can resolve confusion by themselves. If not, what help they need, cognitive support or strategic support. Besides, you should also consider whether they are motivated to resolve the confusion when they get stuck. Okay, thank you.